Everybody, welcome back to Leosophy. Just a heads up, the virus video on BitChute has been giving me trouble lately. So hopefully this one will upload, and hopefully the virus one will eventually process. There's been plenty of times lately where I've had to delete it and then re-upload, and I don't know what their deal is. I don't know what's going on with that. But anyway, just letting you know, if you don't see it, that's the deal. Any video that doesn't get posted on BitChute, it's not that I didn't post it. So anyway, I got 3 questions, and I'm gonna jump right in. Is creatine cheating? No, not at all. I mean, I guess different people have different standards, but creatine is one of the most researched, actually it's the most researched supplement for muscle gains, and I do every now and again I'll see a puff piece about how some psycho using too much creatine, which is almost like anabolic steroids. He beat somebody up because he lost his temper or whatever. Anyway, no, it only does 2 things. I feel like I had this question before. Anyway, it only does 2 things. One, it increases the amount of free ATP in your system, which means that you will have more stamina. And 2, and this is the big one, this is what makes it work. It makes your muscle cells more, what's a good word for that? They tolerate a higher, or receptive, that's a good word for it. They're receptive to a higher concentration of water. Since your cells are basically like water balloons anyway, when your muscle cells swell up with water, it simply adds more mass. It's just water mass, water weight if you want to call it that, but it just makes those cells bigger, and that means, more mass means more force, mass and energy, force. So you're able to lift heavier for a while. That's all it does. It just helps with that. So it's not cheating at all. I don't use it, but the reason I don't use it is it just gives it's like the only thing, you hear, oh, tacos give me heartburn, hot dogs give me heartburn. That's the only thing that consistently will give me heartburn is creatine. So that's why I don't take it. Yeah, I hope that answers it. Let's see. Next question. Let me draw it up. Wait. Dang it. I didn't pause it. Is transhumanism feasible? Long term, it's plausible. Short term, no. And I understand people's concerns, but at the same time, in my opinion, it's no different than any other form of progress. Glasses are not natural, so why should glass eyes be natural? Glass eyes aren't natural, so why should LASIK be natural? LASIK's not natural, so why would cybernetic eyes be natural? Cybernetic eyes aren't natural, so why would a cybernetic body be natural? The appeal to nature, it only goes so far. I mean, I can understand people's reservations, but yeah, I think in the long term it is feasible. It's just the real question is, when is that going to happen? In the long term, I think probably within the next 50 years, but that's anybody's guess, really. Yeah, that's a more subjective one. Last question. Under what circumstances would parthenogenesis evolve? Yeah, that's a good one. Okay. Well, parthenogenesis is rarely found among species who reproduce purely by asexual means. Generally speaking, if a species uses parthenogenesis, it's either sort of a way to, it's often in shorter-lived animals, and it's a way to sort of increase the likelihood of finding a mate for the next generation, cloning yourself. Scorpions and things like that, for example, insects, arthropods. Oh man, I screwed up when I said that. And a lot of our different arthropods, for example, and fish and other short-lived animals. And whenever you normally see parthenogenesis, it's usually a supplement to ordinary reproduction. And the reason for that is because ordinary reproduction increases genetic diversity, and parthenogenesis doesn't. And so naturally, anytime you're going to have 2 species, and one's purely parthenogenic and one's purely sexual, the ones that reproduce sexually are going to outcompete the parthenogenic ones because that genetic diversity is an advantage. But every now and again you find a species that doesn't do this, and the only thing I can think that would explain it, there's two. One, the lifespan is so short, or the rate of reproduction is so efficient and fast that it offsets the lack of genetic diversity. Two, this one's a little weird. The animals themselves are genetically a little bit unstable, and so mutations occur more frequently than they would in most parthenogenic species. Mourning geckos are a good example of that. They get mutations all the time, even though they're parthenogenic. And three, and this is the other possibility, and that would be genetic bottlenecking. Maybe you had a species that reproduced sexually, then it evolved parthenogenic qualities in order to sort of supplement that, like I was talking about earlier. So now they're capable of reproducing and regularly and producing genetically diverse offspring, but they're also capable of producing clones as a way to just encourage the survival of their genes. Just in case something happens to one of the originals, or they can't find a mate within a certain set period of time. But then something happens. Genetic bottlenecking happens. Maybe females of that species get isolated from a patch of males, and something happens to the original population, and what you're left with are just parthenogenic. Another possibility, as I mentioned, if you take a parthenogenic population and a sexual population, you have them compete with one another, the sexual one's going to win because it's going to be more diverse. Well, there's one flaw with that, and that is there's no accounting for the traits that they have. Let's say you had a population that was parthenogenic, and it just happened to have, just by coincidence, really good traits from the outset. In other words, it had a much higher rate of fitness than the sexual population. Well, under that very unusual and unlikely but still plausible scenario, they could outcompete the more diverse population, and as such, what ends up coming out on top is the clones. It is possible. So those are the three scenarios that I can see where a purely parthenogenic population could come into being. Hope that answers what you were asking, and like, share, subscribe, keep asking questions. Bye.